Hello everyone. Today we are going to talk about representation of sparse matrix using linked list, part of data structures using C++ course. A sparse matrix is a matrix with a large number of zero elements. A linked list can be used to represent a sparse matrix efficiently. Each non-zero element is stored as a node in the linked list with its row and column indices and value. The linked list has one head node, which is the starting node, and each node contains the data of the current element and the reference to the next node. This allows for efficient storage and manipulation of the non-zero elements in the matrix. For example, in a sparse matrix of 100 by 100 size, if there are only 10 non-zero elements, the linked list will contain only those 10 elements instead of storing 10,000 zero elements in an array representation. Sparse matrices are matrices in which most of the elements are zero. Storing such a matrix in a dense data structure like an array wastes a lot of memory. One way to optimize this is to use a linked list to store only the non-zero elements of the matrix, along with their row and column indices. Here is an example in C++ that implements a sparse matrix as a linked list. In this example, the sparse matrix is represented as a linked list of nodes, where each node stores a non-zero element of the matrix along with its row and column indices. The add element method is used to add a non-zero element to the matrix. And the display method is used to display the contents of the matrix. The linked list is implemented using a pointer to the head of the list, which is updated whenever a new element is added. In the main method, the sparse matrix is initialized with 5 by 5 matrix, and add element is used to store the values, and the sparse matrix.display method will display the matrix in the console. Hope this was helpful. Thank you for watching.